Okay, this is our notes for section 5.1, and it's on monomials and the rules of exponents. First thing we're going to look at is some vocabulary. There's 4 words here. The first one is a monomial, and a monomial is a group of numbers and variables. Okay, and we all should know what a term is at this point. It's just one term. Okay, they're all grouped together, which means you can't add or subtract anything to each other. I can't have something like x plus 1. Okay, that is not a monomial because I've got 2 things being added together. I could have something like 2x, that's a monomial because nothing's being added or subtracted. But x plus 1 will not work. A constant is a monomial with no variables. No variables, which would mean it's just a number. So something like 3 or 7. Okay, those are constant monomials because there's no variables with those. The coefficient is the number out in front of a variable in a monomial. The number out in front of a monomial. So if we had something like negative 2x squared, the negative 2 part is the coefficient. It's the number out in front. The 2 is the exponent, the little 2 up here. That's called the exponent, but the negative 2 out in front is the coefficient. Now a power is another way of saying the exponent part of a monomial. So if we had something like 6x cubed, the power part is the cube, the 3. And again, the 6 out in front would be the coefficient. And all of that together is a monomial. Now our goal on these problems is to get rid of parentheses and negative exponents. And we're going to look at rules and ways to do that. Okay, and there are 6 of them. Monomials cannot have parentheses and negative exponents. Have parentheses or negative exponents. So again, we got to get rid of those. First thing we're going to look at is negative exponents. And that's our first rule of exponents, and there's 6 of them like I said. Now if we've got a negative exponent, what we would do is move that negative from either the numerator to the denominator or vice versa. And when we do that, it gets rid of the negative. So if I had a negative on top of a fraction, I would move it to the bottom. And I misspelled versa here, versa. Okay. If I had a negative exponent on top of a fraction, I'd move it to the bottom, and that would make it positive. That's all we have to do. So our rule here, if we've got a to the negative n power, that's going to become 1 over a to the positive n. Because we moved it from the numerator, it's really over 1. Now we've moved it to the bottom. We could also have a negative in the denominator of a fraction. So we have 1 over a to the negative n. That's just going to become a to the positive n because I've moved it to the top. Over here, it's moved to the bottom. On the second part, it's moved to the top. We've got 3 examples here. The first one is 5 over, that should be negative x squared. It's kind of hard to see. Let's add that in there. 5 over negative x squared. Well, we have a negative in the bottom, so we have to move it to the top. The 5 does not have a negative exponent, so it's not going to move. It's going to stay at the top. So it's going to become 5x squared, and there's our answer to the problem. We've just moved to the part with the negative exponent to the top. Second example, 10 times x to the negative 3. Well, the x is the only part that's got a negative exponent, so it's going to move to the bottom, and this is going to become 10 over x cubed. Because again, the only thing that's moving is the one with the negative exponent. Our next example is pretty similar, except we've got in parentheses 10x. So it's the quantity 10x to the negative third power. Since this is all in parentheses, the whole thing is going to go to the bottom. So it would become 1 over 10x cubed, like that. The whole thing here has to move to the bottom because it's got a negative exponent. The whole thing has a negative exponent. Last example here, we've got x to the negative fourth on top and a 2 on the bottom. Well, the negative part, the negative exponent, is on top, so it's going to move to the bottom. We have to have something on top of our fraction, so we're going to put a 1 there because that's really the coefficient with the x. It's a 1 out in front. So we've got 1 over 2x to the positive 4 now. The exponent's a positive 4 because we've moved it to the bottom. Okay, and those are our examples for negative exponents, and that's how we get rid of a negative exponent. You either move it to the top, if it's a negative on the denominator, you move it to the top of a fraction, or you move it from the top of the fraction to the bottom. Alright, the next rule is the product of powers. Okay, and what this means is that we're going to multiply two variables, and they could be numbers, but we're going to, in this case, use variables with the same base. And here's our first example. We're going to have x to the fifth times x to the fourth. Now, x to the fifth is really x times x times x times x times x 5 times. Times x to the fourth is really 4x's. So we've got 5x's times 4x's. How many x's do we have there now? Well, we have 9. So that's really x to the ninth because we've got x times itself 9 times. So we would get x to the ninth. And if you look at our exponent here, all we did was add the 5 and the 4. Okay, and that's our rule for product of powers. We add the exponents. So for our rule here, if we've got a to the m times a to the n, that's going to become a to the m plus n power. We're going to add those two exponents together. Now we've got some examples down here. We've got 7x times x to the third. Well, they have the same base, so we add the exponents together. 7 plus 3 is 10, so we get x to the 10th. That's it. Second example, x squared times y to the 6th. This one I'm going to see if you can figure it out. Alright, you don't do anything here. That is its simplified form. The reason we don't do anything is because the x and the y aren't the same. It stays the way that it is. Last example, x to the negative fifth times x squared. Well, now they have the same base on this one, so we're going to add those exponents. Negative 5 plus 2 is negative 3, so we get x to the negative 3. But we just talked about in our rule above there that we can't have negative exponents, so we can't have x to the negative 3. We've got to get rid of that negative. Well, it's negative on top of a fraction, so we're going to move it to the bottom. And since it's the only thing on top, we have to put a 1 on top of our fraction, and it's going to become 1 over x cubed. And those are examples for a product of powers. Okay, our next example, our next rule is the quotient of powers. And like the product of powers, the only difference is that we're going to be dividing with the same base. Okay, so we'll have fractions on here. Something will be over something else, and they'll both have the same base. Our first example is going to be x to the fifth over x cubed. Now, x to the fifth, like we did on our last problem, is really x times x times x times x times x 5 times, over x cubed, which is x times x times x, 3 of them. Now, we can simplify that fraction. We're going to look for what they have in common. Well, the top and bottom both have 3 x's, so I'm going to cancel out 3 x's on the top and the bottom. There's nothing left on the bottom but a 1 now, because we have to have a coefficient out in front of those x's. So there's a 1 on the bottom, and there's 2 x's on top. Well, x times x is really x squared over 1 now, which is just x squared. So that's our answer to this problem. It's x squared. And if we look over here at our exponents, all we really did was subtract the exponents. 5 minus 3 was 2. Okay? So that's our rule. We're going to subtract the exponents for this. So if we've got a to the m over a to the n, it's going to become a to the m minus n power. We subtract them. We've got 4 examples here. First one is x to the 7th over x. Now if it doesn't have an exponent, that's to the first power. We could add that in there if we need to. So that's really x to the 7th over x to the 1st. And we subtract those because we're dividing. Well, 7 minus 1 is 6. So we get x to the 6th for that one. On the second example, we've got x to the 3rd over x to the negative 2. Well, we subtract those exponents. It's 3 minus a negative 2. You've got 2 negatives together here, so we same add reverse. Now it's 3 plus 2, and we would get x to the 5th. On the next example, we've got x to the 2nd over x to the 7th. Well, we're subtracting our exponents. We have 2 minus 7, which is negative 5, so we get x to the negative 5. But again, we can't have a negative exponent. That's not going to work. So to get rid of that negative exponent, since this is on top of a fraction, we have to move it to the bottom, and it's going to become 1 over x to the 5th. And remember, we have to put the 1 on top because there's really a coefficient of 1 out in front of our x to the negative 5th, and it needs to stay on top. Our last example here, we've got x's and y's, and we treat it the same as we normally would, except we're going to figure out the x's, and then we're going to figure out the y's, and we're just going to put them together in the same problem. So let's look at the x's. We've got x to the 4th over x squared. Well, we subtract those. 4 minus 2 is 2. So in our numerator, we've got x squared. For the y's, that was 4 minus 2. For the y's, it's 3 minus 6, which is negative 3. So we get y to the negative 3. Well, again, we can't have a negative exponent, so this part and this part only, the y to the negative 3, is what's going to move to the bottom, because the x doesn't have a negative exponent. So it's going to become x squared over y cubed. And there's our answer to the problem. The next rule is a power to a power. And what this means is that you've got something in parentheses with an exponent raised to another exponent. So it's an exponent raised to an exponent. And our example here is x cubed to the 4th power. So in the parentheses, we've got x to the 3rd power, and then all of that is raised to the 4th power. Well, if we have something raised to the 4th power, that means it times itself 4 times. So this is really x cubed times x cubed times x cubed times x cubed. We have 4 of those because that's what our exponent is. Now we learned earlier in the product of powers rule that if we have the same base like we do here, we've got all x's, we just add our exponents. So that's really 3 plus 3 plus 3 plus 3. 3 plus 3 plus 3 plus 3 is 12. So this is x to the 12th. Now, if we look at our original problem here, another way to get that 12 would be to multiply the two powers, and that's our rule. Okay, we multiply the exponents. So down here for our rule, if we have a to the m raised to the n power, we multiply those two things together, so it becomes a to the mn power. We've got 3 examples here. First one, y to the 3rd raised to the 6th power. Well, we multiply those two exponents together. 3 times 6 is 18, so there's our answer, y to the 18th. That's all we have to do. Second example, y cubed, in parentheses, to the negative 2. Well, we multiply those two exponents together, and we get y to the negative 6. But again, we can't have a negative exponent, so we've got to move it to the bottom, and it's going to become 1 over y to the positive 6. And there's our answer. Last example here, we've got y to the negative 2 to the negative 6 power. We're going to multiply those exponents together. Now when we multiply two negatives, it becomes positive. So we get y to the positive 12th. And this one doesn't have to move because we have a positive exponent now. When we multiply those two negatives together, we got a positive exponent. So we're good. That's all we have to do. The next rule is the power of a product. Okay, for our example for power of a product, we've got the quantity x times y all to the third power, and this is what it means by power of a product. Product would mean you're multiplying two things together, and here we're multiplying the x and the y, and then it's all raised to an exponent. So let's rewrite this. If we've got something to the third power, that means we're going to multiply it by itself third time. So we really have xy times xy times xy. And we learned earlier that if we have product of powers, things with the same base, we add the exponents together. So we've got x to the first, x to the first, x to the first. If we add those exponents, it's 1 plus 1 plus 1. We get x cubed. Y's do the same thing. You've got y to the first, y to the first, y to the first. And when we add 1 plus 1 plus 1, we get y cubed. So there's our answer. We get x cubed, y cubed. And the rule for this is that that exponent has to go to every number or in every variable inside. Okay, so exponent goes to each, I'm going to call them a thing. They would be variables and coefficients. Each variable and coefficient inside the parentheses. Okay, now it is not the distributive property, and a lot of people get that confused. I'm not distributing that exponent to both of them. That does not work. I'm taking that exponent and I'm putting it on the x and I'm putting it on the y. So for our rule here, if we've got the quantity ab to the m power, then it's going to become a to the m, b to the m. And again, it's not the distributive property. That exponent just goes with every variable and every coefficient inside the parentheses. We got two examples here. The first one is the quantity bc to the negative fourth. Well, that exponent, that negative 4, has to go to each one of those variables. So we've got b to the negative fourth, c to the negative fourth. Can't have negative exponents though, and since they're both negative, they're both going to move to the bottom of the fraction. And remember, we have to have 1 on the top of the fraction because there's a coefficient of 1 out in front of those variables. So you get 1 over b to the positive fourth, c to the positive fourth, because when we moved them to the bottom, the exponents became positive. And there's our answer. The next example is the quantity 2xy to the third power. Now this one's a little different because we have three things. We have a coefficient and then two variables. That 3, that exponent, has to go to all of them, so this is going to become 2 cubed, x cubed, y cubed, and we're going to need to simplify that. 2 cubed is really 2 times 2 times 2, which is 8. So it's going to become 8x cubed, y cubed, and there's our answer. Okay, again, I want to reiterate the fact that this is not the distributive property. That exponent has to go to everything, every term and every coefficient, not term, sorry, every variable and coefficient inside the parentheses, but it is not the distributive property. Alright, the last one here is the power of, and I just marked it out, power of a quotient. Okay, quotient means we're going to divide. So we're going to take a division problem or a fraction, and we're going to raise it to an exponent. Fraction to an exponent. So we've got r over s to the third power. Well, if we take it to the third power, that means we've got to multiply it by itself 3 times, so it's really r over s times r over s times r over s. We multiply fractions straight across, so we have r times r times r, which is really r to the third because we add those exponents. Each one has an exponent of 1. 1 plus 1 plus 1 is 3. On the bottom, same idea. We multiply straight across. It's s times s times s. All have the same base. All have exponents of 1, so it's 1 plus 1 plus 1. We get s cubed. There's our answer. Okay, so for our rule, it's similar to our power of a product. Because in the power of a product, we said that that exponent has to go to everything in the parentheses. Here, that exponent needs to go to everything in the numerator and everything in the denominator. It just has to go to both. So for our rule, if we have a over b to the n power, it's going to become a to the n over b to the n. We've got two quick examples down here. First one is a over b to the negative n power. Using our power of a quotient, that means that this exponent out here has to go to the top and the bottom. So it's going to become a to the negative n over b to the negative n. But again, like we've seen in our examples before, we cannot have negative exponents. So the a to the negative n is going to move to the bottom. The b to the negative n is going to move to the top. They're just going to trade places. So it's going to become b over n, b to the n over a to the n. And there's your answer. They flipped places because the a has a negative exponent, needs to move to the bottom. B has a negative exponent, it's got to move to the top since it's in the denominator. Last example here, we've got 6x over y squared all to the second power. Well, the power of a quotient says that that exponent has to go to the top and the bottom. So we're going to rewrite our problem. It's going to become 6x squared over y squared squared. Now we're going to use our other rules for exponents to simplify that. Well, the top part is the product, the power of a product. We have two things being multiplied together and they've got an exponent on the outside. So that 2 has to go to both things on the inside of the parentheses. So it would become 6 squared x squared. On the bottom, it's a power to a power, so we multiply our exponents together. 2 times 2 is 4. It's y to the 4th. We've got one more step. We need to simplify the 6 squared. 6 squared is really 36. So it's going to become 36x squared over y to the 4th. And there's the answer to our problem. Now we've gone over in this video the 6 rules for exponents. And they were negative exponents, the product of powers, the quotient of powers, power to a power, power of a product, and the power of a quotient. And it's important that you understand the differences between all 6. And then in class, we are going to do examples that combine all 6 properties in one. So make sure that you understand how to get rid of negative exponents, how to get rid of the parentheses for each one of these different rules. And those are your notes for section 5.1.